everyone. So basically, in today's GFG POTD, we have to solve exit point in a matrix. So as the question given here, given a matrix of size n cross m with zeros and ones, you enter the matrix at cell 0, 0 in left to right direction. Whenever you encounter a 0, you retain it in the same direction. Else if you encounter a 1, you have to change the direction to the right of the current direction and change that one value to a 0. You have to find out from which index you will leave the matrix at the end. So as the example given here, so this is my example here where the size of rows is 3 and size of column is 3 and we have a matrix like this. So if I'm going to explain this matrix, then according to this question, we actually taking entry from this position, that means 0 0, and we need to move from left to right continuously, and if we get 1, then we need to count that one value and move to the towards right right direction with respect to that direction. That means currently I'm um, walking in our currently I am traversing through this direction, left to right direction, but here we get 1. So at this position I have to change my direction to right. So the direction will change towards this side, because if I'm going to this side, the right side value will be in this side, so I need to come here. Again I'm finding a 1, again I'm getting a 1, so I need to again count this value, and again I have to move towards right side. So till I am getting here, the right action will be in this side. So as I am getting 0, so for 0 I need to simply travel. Okay, I need to simply walk in the same direction. So I am getting outside from this indices, so I need to simply turn the output as 1 and 0. Okay, because from this position I am getting outside. Okay, so here's here it is explained the question. Okay, here we actually enter the matrix at 0 0 position, that means from here, and then move towards 0 and 1. Okay, that means when we actually reach here, we get 1, and we have to count this 1 as 0 and move towards right side. That means we have to come in downside direction. Okay, then again I am getting a 1, so I need to count this value and move towards right side with respect to this direction, and again I'm getting 0, so I need to simply move out from this, and I'm getting this indices as my output. Similarly in this example, here the size of rows is 1 and the size of column will be 2. Okay, so here I'm getting 0, so I have to simply traverse from left to right direction. Again I'm getting here 0, so again I have to simply move forward, but there will be no any element here, so I have to simply exit from this position, and I'm getting the indices as 0 and 1. So this is my output here. Your task, you don't need to read or print anything. Your task is to complete the function find exit point, which takes the matrix as an input parameter and returns a list containing the exit point. Here expected time complexity is order of n cross m, where n is equal to number of rows and m is number of columns. Expected space complexity is order of n. Okay, so this is the important thing, constant. That means the size of rows must be greater than or equal to 1 and the size of column must be greater than or equal to 100. Okay, so basically this question is asked in Samsung, and topic text, matrix and data structures. So for solving this question, first of all I'm going to explain this question in depth. So as the question is given here, I'm going to explain it further. Okay, so currently I'm standing on this position, that means on 0 0, and again that question I'm repeating again actually. So I have to traverse toward this side, that means left to right direction, and while traversing I'm getting here 1, so I need to I need to count this value, and I need to make it 0 first of all, and then I have to move in the right direction. So what will be the right direction for this position? Contain this position, let's suppose this is my ending point. Now from this position my right action will be in this side. Okay, again, let's suppose this is a way. Actually you're traveling on the road. Let's say this is a road and this road is actually ending here, or let's suppose moving in the right direction. Then you have to also change your direction first. Okay, and again this here I am getting 1, so I need to count this value, and again I need to make it 0, and again I need to move, I need to change my direction because I'm getting a 1. So for this my right direction will be this one, and I'm getting a 0, so I need to simply move forward, and I'm getting outside. Okay, I'm getting exit. I have to take my exit. Okay, so my last indices will be, and that means 10, which is my output basically. Okay, which is my output for this particular question. Okay, now for solving this question we have to take an approach. We have to take a situation that let's suppose if there's an element existing here, then what I can do here, let's suppose I'm traversing from left to right direction, so I'm getting a 1, so simply I have to count this 1 as 0 and move toward the right direction, but again I'm getting a 1, so again I need to count this value, and then let's suppose again I am moving towards right side. But in this problem, or in this approach, we are again getting the value 1. So while count this value, I'm and changing the right direction as right, and getting the same position where we started. So this creates a type of like cycle, we can say that. So for solving this problem, actually this, we can say that this uh, will be this will be repeated until we come out the boundary, right? This situation is actually repeated till we are not fulfilling all those conditions and getting exit from this loop. So for solving this question, we have to we have to assume the 4 stages of direction. So let's solve this question. First of all I am saying that I am on the position 1, so int, sorry, 0. Okay, and int j is equal to 0, and I have to also define all about my direction. Okay, direction, let's say direction is equal to 0. So yeah, currently I'm on this position, so I have defined all the things. Okay, now I need to traverse. So while traversing, what I can do here, while I need to give a condition, while I while I is less than n, the size of rows, and while j is less than m, and I need to also give the condition. Okay, now my value of I must be greater than or equal to 0, and j must be greater than or equal to 0. Okay, while doing this, what I can say, if if my matrix here, I have a vector of matrix. Okay, so if my matrix of value I and j is equal to 1, we can say that. So whenever we get the value as 1, what you can say, I need to encounter the value 1 and make it 0, and simply we have to change the direction. Simply we have to change the direction. Okay, all right. So I can say here that is matrix of I and j, we have to simply change. Okay, now the value of 1 will become 0 while getting 1. Okay, and we have to simply uh, increment our direction. That means we have to move forward, we don't have to wait there, right? But in which direction we have to, so we have to move on towards right direction with respect to that position. Okay, so what I can do here, as I'm saying that in this example we have actually basically 4 stages, okay, for solving these types of problems. So here we are going to assume um, here we actually, first of all, here we are going to assume the direction, and okay, direction we have to take a model for this. Okay, for my 4 directions or 4 stages, we can say 4 stages for the direction. And again I need to check here, that means if my direction is equal to, if my direction, what I'm deciding here, I am declaring direction as dir. Okay, if my direction is equal to 0, okay, that means I am on this position. Okay, currently I'm on this position, so I need to do what? I need to simply move towards my forward position. That means I have to move towards this position. Okay, so for moving here, we know very well that I'm on the same row but changing the column, so I need to simply j plus plus. I have to make, okay, so I have to do j plus plus here. Okay, now similarly I can do it here for else if direction is equal to 1, then what I need to do, if my direction is equal to 1, now currently I'm in this position and I need to change my rows. So actually I'm increment my rows by 1, so here I plus this. Okay, so here I can say that I plus plus. Similarly I can say it here, that's it. If my direction is equal to 2, that means currently I am in this position now. Okay, and I need to change my column, so I have to decrement my column, so j minus minus. Okay, so I am decrementing my here. Okay, and now finally I am on this position, and I need to come back to this position. So what I can do, I am on the same rows here, that means I am in the same this row, and I need to change the column. So for changing the call, actually I am the same column but I need to change the row. So for this thing I need to decrement my row. Okay, so here I minus minus finally. Okay, else if I am the direction 3, then I need to do what? Into I minus minus. Alright, yeah, once I've done all those things, now I'm going to take the values. Okay, basically I have to um, okay, so here this is my condition here. Okay, now once I have done these things, what I have to do, basically I need to come out from this loop and I need to simply return my all the values, okay, or the indices values where I have to take my exit. Okay, I have to take the value, and okay, so here if I'm saying if my direction is equal to 0, I'm going to take my indices from where it will going to take exit. Okay, if my direction is 0, then I can say that return I j minus 1. That means when I'm on this direction, here my value is 0, I and j minus 1. Okay, and okay, if return. Okay, now similarly else if we can say if my direction is equal to 1, then I can simply return I minus 1 position and j. Okay, these are basically my indices. Else if I'm saying that if my direction is equal to 2, then kindly return I and j plus 1. Okay, and then I need to do what? I need to simply return my last position for my I plus 1 and then j. Okay, so yeah, that's all for this question. Now let's check it. Okay, so yeah, we got our output. Let's submit it. So it's submitted. So that's all for the today's problem. Thanks for watching.